back everyone in my YouTube channel Chemistry with Sarika. Last time I had already introduced the classification of halogen derivative of alkanes. Let us see the classification of halogen derivative of alkanes. Basically, halogen derivative of alkanes is classified into two major groups. The first one is monohalogen derivative and the second class is polyhalogen derivative. This monohalogen derivative is also called as alkyl halide, which is further classified into three new classes, that is primary alkyl halide, secondary alkyl halide and tertiary alkyl halides, whereas polyhalogen derivative is further classified in dihalogen derivative, trihalogen derivative and tetrahalogen derivative. Now, let us talk in depth about monohalogen derivative, its definition and its subclassification. Then we'll move on to polyhalogen derivative, its classification, examples and definition. So everything we are going to see in this module. Let us talk about monohalogen derivative of alkanes. I have written two examples. The first example is methyl chloride CH3Cl. Can you see in this example one halogen is there? Now the second example, ethyl bromide. Can you see in this example also one halogen is there? So when one hydrogen atom of alkane is substituted by one halogen atom, the resulting compound which is formed is known as monohalogen derivative of alkanes. Monohalogen derivative of alkane is also called as alkyl halides. These alkyl halides are further classified into three categories. The first one is primary alkyl halide, the second one is secondary alkyl halide and the third one is tertiary alkyl halide. Let us discuss about primary, secondary and tertiary alkyl halide. I am drawing here, pay attention carefully. Everywhere I have drawn alpha carbon. So this carbon will be considered as alpha carbon. Now, can you see why it is called as alpha carbon? Any carbon which is attached to the functional group will be called as alpha carbon. Now, when this alpha carbon in response is connected to one carbon, this example will be of primary alkyl halide. When the same carbon is attached to two carbon, this one will be an example of secondary alkyl halide. When the alpha carbon is attached to three carbon, then this structure will be an example of tertiary alkyl halide. Okay, so I have written the examples of primary, secondary and tertiary alkyl halide. I had satisfied each carbon with the number of hydrogens. So can you see here, this alpha carbon is attached to the one carbon, so is an example of primary alkyl halide. Now in this case, this is alpha carbon as it is attached to the functional group. This alpha carbon is attached to two more carbon, so it is an example of secondary alkyl halide. Whereas this alpha carbon which is attached to the functional group in response is attached to the three more carbon, so this structure will be an example of tertiary alkyl halide. Now let us talk about its definition as well as example. The definition for primary alkyl halide is when halogen atom is bonded to a primary carbon atom. So such structure will fall under primary alkyl halide. Secondary alkyl halide when halogen atom is bonded to a secondary carbon atom, such structure will fall under secondary alkyl halide, whereas when halogen atom bonded to a tertiary carbon atom, such structure will fall under tertiary alkyl halide. Let us talk about the other side of flow chart, that is polyhalogen derivative of alkanes. When more than one hydrogen atom of alkanes are substituted by corresponding number of halogen atom, the resultant compound which is formed will fall under polyhalogen derivative. For example, in this example, can you see there are more than one halogen atom which has replaced more than one hydrogen atom of aliphatic alkanes. Polyhalogen derivative of alkanes is further divided into three major classes. The first one is dihalogen derivative, the second one is trihalogen derivative, and the last one is tetrahalogen derivative of alkanes. Let us talk in depth about di, tri, tetrahalogen with their definition as well as example. Students, can you see here I have written two halogen atoms. So all these examples, all those examples where two halogen atoms are involved in one structure, that example will fall under dihalogen derivative. Now let us talk about trihalogen derivative. Can you see three halogen atoms has substituted three hydrogen atom of aliphatic alkanes. So such example will fall under trihalogen derivative. Let us talk about tetrahalogen derivative. Can you see here four halogen atoms are substituted, means four halogen atoms have substituted four hydrogen atoms. So such example will fall under tetrahalogen derivative. Now see the definition for dihalogen derivative. When two hydrogen atoms of alkanes are substituted by two halogen atoms, such example will fall under dihalogen derivative. Here I have taken the example of methylene dichloride. Now, when three hydrogen atoms of alkanes are substituted by three halogen atoms, such example will fall under trihalogen derivative. I have taken the example of chloroform. Now, the next one, that is when four hydrogen atoms of alkanes are substituted by four halogen atoms, this example will fall under tetrahalogen derivative. Here I have taken example of CCl4, which is carbon tetrachloride. I hope the classification of halogen derivative of alkanes is clear to all of you. Please subscribe my channel, share and like it. Thank you everyone for being with me and watching this video.